and see how we did. Remember that when you have, this is an algebraic expression, okay? It just has a lot of letters. Those are just holding places for numbers, so that when we know what those numbers equal, then we could actually find an answer, a numeric answer. And so basically what it's saying is that we need to take where we see A, and we're going to put in a -3. And where we see B, we're going to put in a 4. And where we see C, we're going to put in a -1. Okay, so first step to simplifying or evaluating these is to plug in what you know and then work from there. So I'm going to put in -3 for A. So I have -3 minus, then I'm going to put in 4 for B. And then I'm going to put in -1 for C. Okay, now one thing that is an easy place to make a mistake is this minus C. We need to put the subtract symbol down, but then the C is negative. And so we're going to have subtract a -1. And so it's real common to just write the minus and then go, oh, well, I already have the minus, so I'm just going to put a 1 in there. But it's actually subtract -1. Okay, once you get it down to this step, now we are at using our rules for adding and subtracting negative numbers, and we're using our order of operations. So this problem incorporates a lot of what we've worked on from the beginning of the quarter. And so if you recall, we talked about that we can change subtraction to addition. I'm going to change this subtract to add as long as I change the sign of the number that follows. So -3 minus 4 is the same as -3 plus -4. And this subtracting a negative is really hard to think of in your head. But you can actually change subtraction to addition and change the sign of that -1 to +1. I tend, after I change my subtractions, I circle the fact that I've changed the sign of the second number. And so now I've got all addition and subtraction, or all addition. My subtractions changed to addition. Now I want to look at my order of operations, and it says I do parentheses first. So I need to do what's inside of these parentheses. And -3 plus -4. When I have the same sign, I add the numbers and keep the sign. Okay, so I've done my parentheses. This still has parentheses around it, but there's no operation left to do. So this says take -7 and square it. That means -7 times -7, which is 49. And 49 plus 1 is 50. Okay. Another important skill is if you just put in your calculator, if you did the square in your calculator and you put -7 squared, it's going to give you -49. And the reason is if you don't put parentheses around that -7, then the only thing it's squaring is the 7, and then it's keeping the negative sign out in front. Because that's what you've told the calculator to do. You've told it to square 7. If you want to tell that calculator to square -7, you have to tell it that the negative sign goes with the 7 that I'm squaring to get +49. So you have to be real careful if you use the calculator to square negative numbers. Also, when you think about -7 times -7, the signs are the same, so the answer is positive. So that's kind of 2 routes to get to that +49. Okay, this is not a simple problem, but it pulls together a lot of the skills we've talked about. So there are questions or things that you'd like for me to show you again or explain in a different way for number 1. So first step is put those numbers in for the letters. And then now we have all numbers and it's a process of working through. You could have also, let me go back to what we had originally. We had -3 -4 quantity squared minus -1. It is possible to put all this in the calculator, okay? And the way I would do it would be, I would open the parentheses and say -3 subtract 4, close the parentheses, hit the x squared button, which is to the left of the 7. Then I want to subtract -1. Remember, the subtract and the negative symbols are different. You can see the subtract symbol is right in the middle. It's a little longer. The negative symbol is a little elevated and it's shorter. And so you have to use a negative right down here on the bottom for a negative number, and a subtract is here with the other operations. And so you could put all that in your calculator to check your answer. Thoughts or questions? All right, let's take a look at number 2. Hopefully you notice that these bars here were straight up and down, okay? Remember, that's called absolute value. So we're going to plug in this number, -5 is going to go in for the X, and -2, excuse me, -2 is going to go in for the Y. So my first step is to plug those numbers right in there. I still have absolute value of 4 plus -5 minus, and then Y is -2. So I'm going to have again that subtract -2. I have all numbers now, so I can calculate an answer. And 4 plus -2, the signs are different. So I subtract the numbers. 5 minus 4 is 1. The 5 is bigger than the 4, so it's negative. And I'm going to take the absolute value of it in just a minute. My absolute value acts like parentheses. So I do that first, and I've got to get a value in here before I can do something with that absolute value. So now we're going to take the absolute value of -1. And remember, that's one way to think about it is how far is -1 from 0 on the number line? It's 1 unit away from 0 on the number line. Or you can think of, it's an absolute value jail. When you get out of jail, it becomes very happy and very positive. So I have 1 minus -2. Again, subtracting a negative is really hard to think about, but I can change that subtraction to addition as long as I make this -2 a +2. And now I have 1 plus 2, which is 3. Thoughts or questions? Feel free to put questions in the chat. If you've got something carefully again.
All right, Mary, we have a question. Just give me a second, though. We're putting it together.
Okay.
Okay, now what's up, Ryan? Where's the -1? This one here? Because she had to simplify the 4 plus -5, right? Which the answer, so when she simplified inside the absolute value, she was left with a -1 inside the absolute value. Okay, but then when we take the absolute value of 1, it's actually, right, we think of it as positive. Does that feel better? All right, I think that we're good now on number 2 from the part.
Okay, but it's a good question. To get to this -1, we've got to simplify what's inside this absolute value, because that absolute value, kind of acts like a parentheses. We got to do what's inside of it before we can take the absolute value. All right, number 3, I should have left more space between these because I'm getting kind of crunched up. Okay, so we've got an X and a Y. I'm going to put in -2 for X. And I have an X in 2 places. So I'm going to put -2 in both of those places. And then I'm going to put the Y, I'm going to put a 3 in for it.
By itself, says, right, so, 5 squared.
So I'm going to have to take -2 and cube it. So I'm going to put, so I know that I have to take that whole -2 and I have to cube it. And then I have -3 times X, which is still -2. Okay, there's X's here and X's here. So I put in a -2 and a -2. And then I'm going to add Y, and Y is 3. So now I'm down to all numbers. And so I can simplify from there. Now I have parentheses, but there's nothing to do inside of these parentheses. They're just setting off the number -2. So I go on my order of operations. After we have parentheses, we have exponents. And so I've got an exponent right here. I need to take -2 to the 3rd power. -2 to the 3rd power means -2 times -2 times -2. One way to look at that answer is negative times a negative times a negative. There's an odd number of negatives, so my answer is going to be negative. And 2 times 2 times 2 is 8. Another way to look at that is -2 times -2 is +4. And +4 times -2 gets me to -8 also. So this -2 to the 3rd power becomes -8.
Yeah, it's kind of like.
I'm done with parentheses. I'm done with exponents. And now I need to multiply and divide left to right. 2 times -8 is -16. 3 times -2 is -6. And then +3. I'm just going to rewrite this up here. Okay, I have a subtract and negative. I can change subtraction to addition as long as I change the sign of this 6 to positive. So now I have -16 plus 6 plus 3. -16 plus 6, the signs are different. So I subtract and get 10. The 16 is bigger than the 6, so it's negative. And -10 plus 3, the signs are different. So I subtract. And I keep the sign of the larger, so I get -7. Okay, I had a little trouble with these. These are not easy ones. These are pulling together a lot of what we've done, and it's putting all those concepts together in the same problem. These problems are very, very similar to what is on page 19 that we said on last Thursday would be a really, really, really good idea for practice so that you can get the hang of pulling all these concepts together. Because while we teach adding and subtracting positive and negative numbers, we teach that, and we teach all these concepts separately. Ultimately, we've got to start pulling them together to get to be able to use them all in the same kinds of problems. So if these you found challenging, make sure that you look at page 19 of your packet, and there's some more practice problems in there, and the answers are in the back. And if you're having trouble with a specific skill, like adding and subtracting the positives and negatives or whatever, then you've got other places in the packet that you can work on them. Okay. So question 4 is actually right out of page 19, because I think it's a really good question in terms of thinking about numbers. Will the value of x cubed always be greater than x squared? Remember, x cubed means I'm going to take the number and multiply it by itself 3 times. X squared means I'm going to take a number and multiply itself 2 times. And so what are your thoughts? Let's get some answers in the chat on yes or no. Will the value?
Oh, sorry, that was me thinking about how I need to maybe change my original answer now that I really think about it.
Okay, so I'd love to see some answers in the chat. This is not to shame you, but this is just to kind of at least get you to invest and think about it just a little bit.
It's better to my exes.
Okay, so then you would say no, right? It will not always be greater is your answer? Okay, why is that?
It can be 1.
What could be 1?
X can be 1.
Okay, yeah, if x equals 1, then yeah, it wouldn't matter. Maybe. Is there another value of x that would affect it when we affect the value of it when we cube it instead of squaring it?
2. No,
So if we take a number, what do you mean 2?
X was 2.
If x was 2, then x cubed would be greater, right?
Oh,
8 is greater than 4. 2 cubed, right?
no. 2. 2.
Yeah.
2 is. Oh, yeah, you're
Right, good. So sometimes the value of x cubed will be greater than x squared. Always? Is it always going to be the case? So you said no, because we know if x equals 1, it's not the case. Any other?
right.
0, if x equals 0, yeah. Then the value would not be greater. Any other thoughts?
Ryan's picked out values I hadn't really considered, actually. When I was answer this question. I was considering some other cases, but actually Ryan's actually proved why this would be, this statement would be false. Okay. This said, will the value of x cubed always be greater than x squared? If you pick a number like 2, 2 squared is 4, 2 cubed is 8. And so that would be yes, x cubed is greater than x to the 4 or x squared. Okay. Ryan picked out 2 cases that are different than the ones I was thinking of. He says if x is 1, then x squared is 1 times 1, which is 1. And x cubed is 1 times 1 times 1, which is also 1. And so in this case, x squared equals x cubed. And also right for 0. If x is 0, x squared is 0 times 0, which is 0. And x cubed, if x is 0, is 0 times 0 times 0, which is also 0. And that's another case where x squared is equal to x cubed. So then I guess my next question, so his cases prove that that's not true. X cubed will not always be greater than x squared. Sometimes it's equal to. But is there a case where x cubed would be smaller than x squared?
What value could we give x that would make it smaller if we cubed it?
Curtis?
Is it a positive and negative thing?
Curtis says, is it a positive or a negative thing? And
Positive.
not odds and evens. Let's key in on your first statement, positives and negatives. Okay. What if I try x equal -1? What is -1 squared?
1.
is 1, because -1 times -1 is +1. And what if I put in x cubed? That means -1 times -1 times -1, which is, Curtis says it's -1.
Yep, you got it too, Ryan. Good job.
And now we have a case where x squared is bigger than x cubed. And so that's the case I was thinking of, Ryan. I hadn't even considered 1 and 0.
Either.
So it goes to show you that sometimes you can have different insight, just the way you work through the problem. You can have different insight that leads you to the same place. And that was, no, the value of x cubed is not always greater. Sometimes it's equal. And sometimes x cubed is smaller than x squared, or x squared is bigger than x cubed. Okay. Basically, if you choose any negative number, the square of the negative number will be positive, but the cube of the negative number will be negative. And so you get that role reversal. And so when you're facing problems that you're like, particularly problems that use words and I don't give you a specific problem to answer, it's always a really good idea to just simply start checking numbers. Is a good strategy for answering questions like these. Is pick some numbers and make sure you pick positives, make sure you pick negatives. Ryan did something I hadn't thought of. It's always good to consider what happens with 0 and 1, but particularly 0 is always a good value to test. So you want to test positives, you want to test negatives, and you want to test 0 if you're trying to just kind of work through a problem by checking answers. So that problem comes straight from page 19, number 8. Number 7 on page 19 is a great problem also to really get you to think about problems. And it's not just a straightforward problem. It asks you to work through some different scenarios. And that's always good practice for trying to really think through the math. Are there questions on any of these? Number 4 or any 1 through 3 too? If we're kind of twisting your brains in knots, that's okay. It may feel really uncomfortable, but that's part of the learning process. Any questions?
Questions?
All right, so the next topic we're going to look at, I'm going to illustrate with kind of a silly video. And so this will give your brain hopefully a little bit of a rest for a moment before we start into something new. So just sit back and watch this, and then we'll talk about what its application is to math.
Hi, welcome to Burger Nation. How may I help you today?
Let me get 2 hamburgers with just pickles, 2 cheeseburgers with another cheeseburger, everything on them, 4 more hamburgers with everything, a cheeseburger with no pickles, and a cheeseburger with nothing but pickles, 2 more hamburgers with everything but onions on one, everything but pickles, mustard, and tomatoes on the other, 3 large fries, 6 medium fries, 1 large fry, a junior fry, and 2 junior fries, 3 more cheeseburgers with extra cheese and bacon, 2 more junior fries, a hamburger with everything, 2 more hamburgers with everything, and 2 more hamburgers with everything, 4 large Cokes and a large Sprite, 2 large Cokes and a small Sprite, 5 large Cokes and 1 large Coke and a small Coke, 3 small Cokes and a small Coke and a small Coke.
Okay, will that be everything?
Yes.
Gotcha. That's 2 hamburgers with just pickles, 2 cheeseburgers with another cheeseburger, everything on it, 4 more hamburgers with everything, a cheeseburger with no pickles and a cheeseburger with nothing but pickles, 2 more hamburgers with everything but onions on one and everything but pickles, mustard, and tomatoes on the other, 3 large fries, 6 medium fries, 1 large fry, a junior fry, and 2 junior fries, 3 more cheeseburgers with extra cheese and bacon, 2 more junior fries, a hamburger with everything, 2 more hamburgers with everything, and 2 more hamburgers with everything, 4 large Cokes and a large Sprite, 2 large Cokes and a small Sprite, 5 large Cokes and a small Coke, 3 small Cokes and a small Coke and a small Coke. Is that correct?
Not quite. I wanted 2 hamburgers with just pickles, 2 cheeseburgers with another cheeseburger, everything on them, 4 more hamburgers with everything, a cheeseburger with no pickles, and a cheeseburger with nothing but pickles, 2 more hamburgers with everything but onions on one, and everything but pickles, mustard, and tomatoes on the other, 3 large fries, 6 medium fries, 1 large fry, a junior fry, and 2 junior fries, 3 more cheeseburgers with extra cheese and bacon, 2 more junior fries, and a hamburger with everything, 2 more hamburgers with everything, and 2 more hamburgers with everything, 4 large Cokes and a large Sprite, 2 large Cokes and a small Sprite, 5 large Cokes and 1 large Coke and a small Coke, 3 small Cokes and a small Coke and a small Coke.
Oh, okay, that's 1 large Coke. Sorry, got it now. Is that for here or to go?
I'll have it here.
Okay, that'll be $207 even, sir.
Ooh. You know what? I only have $196 on me. I'm like 11 bucks short.
Okay, well, if we got rid of 5 large fries and 4 large Cokes, that would be $11. Or 3 cheeseburgers and 1 small Sprite would be $11.
Okay, what about 2 large Cokes, 2 cheeseburgers, and 2 large Cokes?
No, that's $13.11.
What about 2 large Sprites, 2 cheeseburgers, and 2 large Sprites?
That would be the same.
$13?
$13.11.
All right, take off the 3 cheeseburgers and a small Sprite.
Oh, okay.
Oh, wait. So now I'm getting 2 hamburgers with just pickles, 4 more hamburgers with everything, a cheeseburger with no pickles, and a cheeseburger with nothing but pickles, 2 more hamburgers with everything but onions on one, and everything but pickles, mustard, and tomatoes on the other, 3 large fries, 6 medium fries, 1 large fry, a junior fry, and 2 junior fries, 3 more cheeseburgers with extra cheese and bacon, 2 more junior fries, and a hamburger with everything, 2 more hamburgers with everything, and 2 more hamburgers with everything, 4 large Cokes and a large Sprite, 2 large Cokes and 5 large Cokes, and 1 large Coke and a small Coke, 3 small Cokes and a small Coke and a small Coke.
That's correct.
Great, here you go.
Thank you, sir. Listen up. Ordering 2 hamburgers with just pickles, 4 more hamburgers with everything, a cheeseburger with no pickles, and a cheeseburger with nothing but pickles, 2 more hamburgers with everything but onions on one, and everything but pickles, mustard, tomatoes on the other, 3 large fries, 6 medium fries, 1 large fry, a junior fry, and 2 junior fries, 3 more cheeseburgers with extra cheese and bacon, 2 more junior fries, and a hamburger with everything, 2 more hamburgers with everything, and 2 more hamburgers with everything, 4 large Cokes and a large Sprite, 2 large Cokes and 5 large Cokes, and 1 large Coke and a small Coke, 3 small Cokes and a small Coke and a small Coke.
Okay, that's 2 hamburgers with just pickles, 4 more hamburgers with everything, a cheeseburger with no pickles, and a cheeseburger with nothing but pickles. 2 more hamburgers with everything but onions on one, and everything but pickles, mustard, tomatoes on the other. 3 large fries, 6 medium fries, 1 large fry, a junior fry, and 2 junior fries. 3 more cheeseburgers with extra cheese and bacon. 2 more junior fries and a hamburger with everything. 2 more hamburgers with everything, and 2 more hamburgers with everything. 4 large Cokes and a large Sprite. 2 large Cokes and 5 large Cokes, and 1 large Coke and a small Coke, and 3 small Cokes and a small Coke and a small Coke.
That's correct.
Coming up.
How many ketchups would you like with that?
Just one's fine.
Sure. There you go. Have a good day, sir.
Thanks, you too. Man, that hit the spot. My compliments to the chef.
Compliments to the chef.
Ah?
Never mind. What else can I get for you today?
What do you have in the way of desserts?
Ooh, we've got apple pie and cherry pie, Boston cream pie, and brownies.
I'll have a brownie.
Okay, that's 1 Boston cream pie.
I said a brownie, you idiot! Can't you get a simple order right?
Okay, let me get out of here. So, you may wonder what the heck that has to do with math, and I'll hopefully make that clear eventually. A silly illustration of how would it have been easier for that guy to order all that food?
3x burger square.
Ryan says 3x burger squared.
I doubt they would have known what that meant. But seriously, if you've ever been a server, if you've probably never experienced anything that crazy, but how would it have been easier? How could they have ordered that easier for both parties?
What made it so complicated?
Yeah, that's good. What made it so complicated? It was long, but besides being long, what made it so complicated? The what? A number code? Like meaning he'd ordered it online or something instead?
The order it was in.
Okay, what order it was in? How could it have been in a different order or simplified?
They could have said the amount of stuff they wanted.
Okay, so instead of saying 2 burgers here and then the same 2 burgers later, they could have put them all together, right?
Yeah.
Know what you mean? Okay, yeah, this idea we could have, if they'd organized, you'd organize the order, so instead of, you heard like medium fry maybe 3 times at 3 different places in the order. If he'd put those all together instead of 3 medium fry here, 2 medium fry there, and a medium fry here, if he would have said 6 medium fries all at once and combined those things that were alike, it would have made the order much shorter. It's still complicated, but much shorter. If you think about if you've ever had a big group of people and you guys decide to order out or call in an order and you're trying to get everybody's separate order, hopefully before you call the order in, you buy things that are alike so that you're ordering, or if you're ordering coffee, you order 2 lattes instead of a latte and an Americano and another latte. Hopefully you, for your sake of hopefully getting your order right and the server, you combine those things that are alike so it's not so long and confusing. Well, that is basically what we're doing in math today. We are simplifying things, simplifying expressions,
On page 20.
which is page 20 in our packet. It says simplifying expressions. Give me just a moment to find these. Oh, okay. Sorry. Is this your first day here? Yeah. Sorry. Page 20. Okay, so if we look at page 20, simplifying expressions is basically what that silly skit was supposed to kind of illustrate, that we can simplify and put together orders that are the same. Okay, and we're going to be doing the same thing now with algebra. And if you look, we have this expression 4x plus 9 plus 3x minus 1. If we approach this problem the way we have been with evaluating expressions, when they tell us the value for x, when x is 2, what we've been doing is just substituting in every time we see an x, we put in the 2. And so this problem, we're going to replace this x with 2 and replace this x with 2. And then we get this statement, and or order of operations would tell us we do multiplication before we do addition and subtraction. So we would multiply the 4 times 2 to get 8. We'd bring down the plus 9. We'd multiply 3 times 2 to get 6, and we bring down the minus 1. And then we can add and subtract left to right. 8 plus 9 is 17. 17 plus 6 is 23. And 23 minus 1 is 22. Totally valid way to do the problem. But this is kind of like the guy who was ordering 4 cheeseburgers and 9 Cokes and 3 more cheeseburgers. And oh, I'm going to take away a Coke off my order. We can work this problem in a different way. And that is 4 cheeseburgers plus 3 cheeseburgers is the same as ordering 7 cheeseburgers, and 9 Cokes take away a Coke, we're left with 8. And so we're going to be working with this idea of going from here to here is called simplifying an expression. And it's that process of taking that long order and putting together the things that are the same. And so to convince you, you get the same answer. When x is 2, we're going to take this x and we're going to substitute 2 in for, there's only one x now to put 2 in for. Here I had an x here and an x here that I had to substitute 2's in. Here I have this x, I put in the 2. I have 7 times 2. I do that before I add. 7 times 2 is 14, and 14 plus 8 is 22. The same answer. And so from the first expression to the second expression, we have simplified the expression by pulling together things that we can add and subtract and pull together.
Can it be negative?
Can it be a negative what? I don't think oh, okay. Brian's giving us a hard time as per usual.
Okay. All right, so, and you can see these expressions have the same value. These expressions are called equivalent expressions, meaning they have the same answer. And what we've done is we've simplified the hamburger order from expression 1 to expression 2. And so if you see this example 1, this is another order where we've got things that are the same. We have 2x and x, that's like 2 cheeseburgers and another cheeseburger. And then we have numbers that we can always combine together. And so what we're going to do, and one thing that can be really helpful when you're working with these kinds of problems is to underline or circle things that are alike. This 2x and the x, that'd be like 2 hamburgers and another hamburger. I can combine or simplify those things, or you can use highlighters. And then the 2 and the -4 can go together because those are just numbers. And so if I have 2 hamburgers and another hamburger, remember just an X by itself is understood. If I say I want a hamburger, you know that I mean 1. And if I have just an X, that means there's just 1 X, 1 hamburger and 2 hamburgers. These 2 together make 3 X's or 3 hamburgers. And now I also I can do 2 - 4. Again, I typically would want to change that subtraction to addition and change the sign of the second number. So now I have 3x plus 2 plus -4. My signs are different, so I subtract and I keep the sign of the larger. So I end up with 3x plus -2. Now, if you look, the answer they wrote down looks a little different than mine. Are these the same answer?
No.
Okay, they look different, but the question is, are they equivalent?
3x - 2 versus 3x plus -2. Are those the same? Did I misspeak?
No.
Okay.
We can change subtraction to addition as long as we change the sign of the second number from positive to negative or vice versa. So these 2 expressions are actually equivalent. Okay, so these 2 are equal. Either one of these answers will give you the same. When you know what X is, they would both give you the same answer. So if you're not quite convinced, let's say X equals 2. If I put in 3 times 2 minus 2, or I put in 3 times 2 plus -2, 3 times 2, I do multiplication before I do my addition and subtraction. 3 times 2 is 6, and 6 minus 2 is 4. For this one, I do 3 times 2 before I do my addition. 3 times 2 is 6. 6 plus -2, the signs are different, so I subtract and I keep the sign of the larger. The 6 is positive, so the answer is positive. And these 2 are equal. These 2 expressions are considered equivalent. If you're looking for a multiple choice answer, you'd probably be most likely to see this answer as a multiple choice. But if you got this answer, then you would need to know that those two are equivalent. Okay. But the process of simplifying an algebraic expression means we're collecting up the things that are alike and doing the operations we can do. Just like in an order, we collect up the things in the order that are the same, and so that we can simplify and make our order as easy as possible. Okay. So the second example here, I have negative 6k plus 3 plus 2k minus 7. These two things are alike. The k's are the same. And so that's like adding hamburgers and hamburgers together. And then I have numbers that I can add and subtract. So if I'm going to put together negative 6k plus 2k, I'm going to put these two together. I'm basically adding and subtracting just the number in front. Okay, we don't often talk about negative hamburgers. So this is where the algebra starts to veer off from the real world in terms of hamburgers, but it's the same idea. I have I have k things, negative 6k things and 2k things, and I'm going to combine them together. And so I'm going to add these two numbers, negative 6 plus 2, just like I added 2 plus 1 up here. And negative 6 plus 2, the signs are different. And so I'm going to subtract the numbers and get 4. It's negative because the 6 is bigger than the 2 and the 6 is negative. Negative 4k plus 3 minus 7. And now I can combine these as well. 3 take away 7. If you know how to do that without changing it to addition, you can do that. Or if you don't know what 3 minus 7 is, you can change subtraction to addition as long as you change the sign of the second number from positive to negative. And now I have negative 4k, 3 plus negative 7. The signs are different. And so I subtract them. I keep the sign of the larger number. 7's larger than 3, and so I have a negative 4. And once again, negative 4k minus 4, I can change that subtract to add, and the 4 to a negative 4, and so these two expressions would be considered equal or equivalent.
I have one problem.
Okay, what's your problem, Ryan?
3 plus 7 is 10.
3 plus 7, but it's positive 3 minus 7. I don't, where are we at? Pardon? Here?
It was 3 minus 7. And then I changed that subtract to add, and this negative, or the positive 7 to a negative 7. If you can look at 3 minus 7 and know that's negative 4, you don't have to change subtraction to addition and change.
Click there. A little bit.
Yeah.
So yeah, so all Mary's doing to try and help us remember is, since it's plus 3, or sorry, positive 3 minus 7 is the same as, right, positive 3 plus negative 7. And then we know, right, the signs are different, subtract, keep the larger sign. So if you have a different way, but you're still getting to negative 4, that's okay. But does that make sense, how those combine? Maybe. Okay.
Let me show you here on the calculator. 3 minus 7 is negative 4. And 3 plus -7 is also -4. So when we went through the adding and subtracting positive and negative numbers, we talked about 3 minus 7 is a harder thing to think about, starting with 3 and then subtracting away a bigger value than you have. And so one way to compensate for that is you can change subtract to add, but you can't just randomly change subtract to add without doing something to offset that change. Because if I just change subtract to add, it would be like I'm just going to, instead of adding money to your wage and giving you a raise, I'm just going to subtract money, and you wouldn't think those are the same. If I tell you I'm going to increase your wage and then I take away money, you're not going to say those are equivalent. And so to offset changing subtraction to addition, this 7 is positive, and if we change it to negative, then we can use our adding rules and we get to the same answer. Okay. If you're a person who can look at 3 minus 7 and go, okay, if I have 3 and I'm taking away 7, I'm going to end up -4 in the whole. If you can look at those and get to -4, that's totally fine. The hardest ones, and a lot of people can see this. If I have 3 and you want to come take away 7, I'm lacking. I'm in the whole 4. A lot of people can see that problem, and then the issue that most people have, hence why we teach this rule, is what if I have 3 minus -7? These are the problems that stump people, because if I have 3 but you're going to take away 7 negatives, what the heck is that? Okay, that's a really hard concept to get your head wrapped around. And so if you know the rule that I can change the subtract to add, as long as I change the sign of this number from negative to positive, then that gives you a way to solve this one. And in case you're not convinced of that, 3 minus -7 is 10, and 3 plus 7 is 10. And so we're showing you a way to make something that looks really hard and is hard to calculate by logic. We're turning it into an easier problem. Okay, likewise, if we have -3 take away -7, that makes people's brain explode. You know, if I'm at -3 and I'm going to take away -7, what the heck does that mean? And in the real world, it's hard to give you something that you can grab a hold of that will help you work through that. But if you trust me that you can change this subtract to add, as long as you change this -7 to +7, now we have a problem we can do. -3 plus 7, I subtract because the signs are different. I keep the sign of the larger, which is 7, so it's positive. And give me 1 minute, I'll finish this, and if someone's got a question, I'll answer it. If I put in -3, subtract -7, I get 4. And if I get -3 plus 7, I also get 4. So we are taking and making an equivalent expression that's easier to solve than the original problem. All right. Given that input, are there thoughts or questions either on this or what's on the other side?
Any better, worse, same? Hard to say.
Okay.
Well, Sally,
For mastering positives and negatives, bottom line is you've got to come up with a method by which you can find the answer, number line, rules, and then you got to practice them well enough that they become second nature for you. Okay. The good news is you can use the calculator on the GED. Bad news is the first part of the GED, which has just straight number problems, which in some sense is easier than all the word problems, you can't use the calculator. And so you need to have some facility, some way to find some answers with adding and subtracting positive and negative numbers. Okay, so let's take a look at these on this page. So
Gotta
Number
take off the,
Yeah.
all right. Well,
five,
some of those pages that we already went past, okay?
I'll do it right now.
Good, the answers are in the back.
Okay, alright, oh, okay, thank you.
Yeah,
five
Sorry.
X subtract 2X. This would be like someone saying, I want 5 coffees. No, wait a minute. Let's take away 2 of those coffees. How many coffees are you ordering? We're ordering 3 coffees. And so basically I'm just subtracting 5 minus 2. If you think about an X as a actual thing, if I have 5 of them and I take away 2 of them, I have 3 left. Number 2, it gets a little more challenging because it's, we don't talk about having -6 things, right? But I have -6 plus K, -6K plus K. And that's the idea of that's just 1K. And so just like I just subtracted the 5 and the 2 to get 3, all I do here is add the -6 plus 1, and I get that many K left. So -6 plus 1, signs are different. So I subtract, and the 6 is bigger than the 1, the 6 is negative, so I have -5K. All right, I'm gonna give you about, so about 10 after, a little less than 10 minutes. I want you to work on these on this first page, and then we'll discuss them before we go on to the next page. So see what you can get done. You may not finish them all, and that's totally fine. But give it a try. If you've got questions, shoot me in the chat. There are answers in the back that if you want to check yourself, or you can run it by me.
Mary. Mary,
Yes?
if there's a letter by itself like that, we put the invisible one, right?
And yes, absolutely.
Okay.
Sorry, Dan, take up your page, but I can delete it now if you need me to.
That's fine. All right, let's take a look at these. I did some highlighting to hopefully help you kind of see things that go together, and it might be a really good idea to get colored pencils or highlighters to try and help visually keep in mind what goes together and what can't go together. So when I look at this number 3 at the bottom, I have t's here with 7 and I have t's with -9. And then 5 doesn't have a t. So I'm not going to be able to combine that 5 with anything with a t, because that would be like, you know, coffees and French fries. The things that go together are the things that have the same letter. And so if I have 7t and I take away 9t, think about 7 and subtract something that's bigger than what you have, you're going to end up in the negatives. And you're going to end up with -2t plus 5. Or you can change that subtract to add and change it to a -9. I can't put -2t plus 5 and get something else. Okay, that's like ordering hamburgers and French fries. They're not what we call like terms. We're combining things that are alike. So if we look at number 4, we have things that are alike in 2a and 9a, and we have things that are alike in that we just have the numbers -9 and +6. And so we can combine the things that are alike. These two things are alike. 2a plus 9a makes 11a's. And this you can think of as -9 plus 6. Okay, we could change that subtract to add and make it a -9, or you can just look at that and say, I'm going to call that -9 plus 6. -9 plus 6, the signs are different. So I subtract and I get 3, and I keep the 9 as negative and I keep that negative. And so I could write either 11a minus 3, or I could write 11a plus -3. Those are equivalent. But I cannot put the 11 a's, those a's, and combine it with the 3, because the 3 doesn't have an a with it. So don't just keep combining everything. Okay, you got to make distinctions between which ones that have letters that are the same and which ones are just numbers. So for number 5, we've got M's in the middle, and then we've got plain numbers on the outsides.
Mary, can we stop and ask a question? Sorry,
Yes,
Flo,
sure.
you want to mute? What's up?
No. Not her. Hard. Subtract.
How do we know what's negative and what's subtraction, Mary?
Okay, well, if I have this -9 plus 6, you can think of that as subtraction. And if you can think of that as subtraction, that's the same as adding a negative. And so that subtract 9, you can write add a -9, or you can just say, well, that's equivalent to -9. So I'm just going to leave it because there's a minus sign out in front.
So we wouldn't want to think of the term as -9 because that might mess us up down the road.
No, it is -9. What I'm saying is you can look at that subtract 9 and say that's equivalent to -9.
Oh, okay.
Because subtract is equivalent to adding the -9.
So if the negative is to the left of that number or term, it kind of is stuck on there as a negative, if that makes sense. No? So like over here, right, in number 2, right, the negative is sticking out here. So when you look at this -9, right, the negative sign is to the left of the number. So it's affecting the 9, so you could think of it as -9. So if that minus is to the left of the number, you
And
can
it-
treat it as a negative number.
Because we're subtracting 9. But subtraction's equivalent to adding the opposite. So you may get to a
All right,
point,
we're good.
may get to a point where you stop changing subtraction to addition and changing the sign and just accounting for it by seeing that minus sign in front. Good question. Okay, number 5, we have M's in the middle. 7M minus M. One of the students got on and say, can I imagine an imaginary 1 in front of that M? Exactly, you can. You can write it if you want to. Okay, that's like having, if I say I have an apple for my lunch, I didn't tell you 1, but you know it's 1 because I said I have an apple and it's understood to be 1. And if I have an M, it's understood to be 1M. So this is 7M, subtract 1M, and 7 minus 1 is 6, M left. And then 10 plus 3 is 13. I can't combine the 6M and the 13 because one has an M and one doesn't. So that's all I can do until I know what M is. The number 6, there's only this minus 6y. There's no other y. So that minus 6y is going to stay. And this would be another example. That minus 6y you can think of as, that's minus carries with it. It's a -6. I could change subtract to add and make it a -6. And then I've got 12 minus 5 plus 18. And I can do addition and subtraction left to right by order of operations. 12 minus 5 is 7. And 7 plus 18 is 25. Okay, on 7, 8, and 9, we've got things with 2 different letters in them. And it doesn't matter, we're still combining together the things that have the same letters. Just like we can put hot dogs with hot dogs and hamburgers with hamburgers, we're going to put K's with K's and M's with M's. And so I have a K, which that's understood to be 1K, and I have 1K and a minus 2K. So 1K or 1 subtract 2 leaves me a -1K, or you could just put -K. I don't have to put the 1 in front. And then I have 1M or 1M, take away 9M, and that leaves me with a -8M. So there's a lot of ways to write this one that would be correct. You could write -K minus 8M. You could write -K plus -8M. All those would be considered equivalent. Or -1K plus -8M. All these are equivalent, but I've put together the K's and I've done 1 minus 2 to get a -1, or you can change that subtraction to addition and make it a -2. And then I have 1M subtract 9M, which leaves me -8M or -8M. Number 8, I have C's and D's. I can put together my yellow highlighted AC, subtract 2C. I'm only left with 6C. And then 3D plus 5D makes 8D. I can't put these together because those are like different things. They're not like. And then finally, number 9, I have S's and T's, which I hate it when they use those letters because S's start to look like 5s and T's start to look like addition signs. So it's a very poor choice of letters. So I can put together my S's. I've colored them orange. I have -2. I'm going to rewrite this one so we have everything next to each other. -2S minus 6S minus 8T plus 9T. Okay, I've put together the things that belong together. This minus has to travel with the 6s. Okay, this is a case -2 minus 6 might be a case where you need to change that subtraction to addition and use the rules. I could rewrite this as -2s plus -6s plus -8t plus 9t. Okay, I have the same signs, so I add, keep the same sign, -8s, and -8 plus 9 signs are different this time, so I subtract and get 1t, and it's positive because 9 is bigger than 8 and 9 is positive. Okay, so again, we're figuring out what we can put together, and then we're using our rules of addition and subtraction mostly to combine things together in the simplest order as possible. It's like taking that ridiculous video order and paring it down to everything that is alike goes together, but I can't put fries and hamburgers together. And those have got to stay separate. Okay. Some of the classic ways you'll see these kinds of problems is what you'll see on page 21. They'll often give you a shape and talk about perimeter with these kinds of problems. And perimeter is something that's on our formula sheet for the GED. I think it's also on the formula sheet for the TABE. But it's the idea, perimeter is the idea if I walk all the way around a object, how far do I walk? Right? If I walk this length plus this length plus this length, what's the total amount I walk? That's what the perimeter is. And you get it by adding all the sides together of whatever figure you're looking at. Okay. So for question 10,
Yeah.
which side is the longest and how can you tell it's the longest besides?
Area is a different measurement.
Yep, area is a different, area is how much is contained inside of a two-dimensional figure. Like if we were gonna lay carpet or tile in this triangle, that would be area. Perimeter
But if
is
we
putting a fence
fence around
around
it.
the triangle.
Yeah.
Can you tell me which side's the longest and how you know it's the longest?
Great.
X
Yeah.
plus,
I think I heard X plus 3 is the longest side. That's correct. And how do you know that?
because it looks longer.
Okay, that's that's a valid answer, except 10 says, how could you tell it's longer besides how it looks?
Of course. Pardon? 3 is bigger than 2? That's the start of it, but there's also an X on there. Is that X gonna affect 3 being bigger than 2?
Oh, okay.
Good. Yeah, we don't know what X is, so yeah. So
Remember
X
when I said
3,
sometimes it helps just to substitute some numbers in. Okay,
Mhm.
like if X is 1, this side is 1, and this side is
3, right? 1 plus 3,
2 is 3, and this side is
4.
4. 1 plus 3 is 4. If X is 2, then this side is 4.
4.
2 is 4, and this side is 5. So since I'm adding a greater number to each time I go around these sides, that is the reason, another reason why this side would have to be the longest.
So yeah, you were very much on target with your answer, Angelica, for sure.
Okay, so for number 11, this is a real common way you'll see these kinds of problems is write an expression for the perimeter of the figure. Perimeter, if I'm going to build a fence around this triangular plot of land, I need fencing in the amount of this plus this plus this. It's not very satisfying because you don't know what this is and what that is, but we want a fencing that's whatever this length is plus whatever this length is plus whatever this length is. So you can see I'm adding the first side. I'm adding the first side. Plus I'm adding the second side. Plus I'm adding the third side. And then they'll want you to simplify it. That's what number 12 is, to simplify it. And so I need to collect up all my terms that are alike, like x and x and x are alike, and 2 and 3 are alike because I can add 2 plus 3, okay? What is x plus x plus x?
3x.
It is 3x. If you need,
Good
you can
job.
put out a 1 in front of all of those, but there are 3 x's in my expression. There's 1 here, there's 1 there, and there's 1 there, which makes 3. Okay, and so now we are putting together those that are alike. And then we're going to put together our numbers that are alike. And so our 2 plus 3 is 5. And so the expression that represents the perimeter of this rectangle is 3x plus 5, which you can't go to the hardware store and buy until you know what x is. But if I tell you that x is 4, then you would know 3 times 4 is 12. 12 plus 5 is 17. And then question 13 and 14, they're going to have you evaluate this expression for different values of x. All right, we are out of time for today. And so again, I would encourage you, math is not a spectator sport. You've got an example here in 10 through 12. And it's going to ask you to do very similar things with this rectangle here and then the square here, and utilizing the information that's given to write an expression, to simplify the expression, and then to find the value of the expression when you have a certain value of your variable, your letter. Okay, answers are in the back. Highly encourage you to work on these and to get some practice, and you can come back with questions. Nice thing is on these, you're working mainly, well, I think all of them, you're going to be working with positive numbers. So whereas the last page had a lot of positives and negatives to sort through, what the nice thing is when we get to real world examples, we almost always have mostly positive. And I think all of these are positive. Okay.
Yay.
I'll stay on for a few minutes if you have questions, but have an awesome day and I will see you hopefully on Thursday.
Everyone doing okay? Sure.